So hello everyone, in this video I am going to discuss more about functions. So do you still remember this notation? So it essentially means that we have a function f, and the job of the function f is to map set A to set B. So if you remember, we have in the definition of a function, an element of A is being assigned with exactly one element from B. All right, so you can think of it like this. The function f will act like a function machine, okay? And the function machine accepts some input x, wherein this x belongs to the set A, right? So what the function machine does is to do some computations or do some operations or to process the input x so it can produce an output f of x, wherein this f of x will be a member of the set B, okay? Now, so if we have this notation, f maps A to B, we call A as the domain and then B as the codomain. So what is the difference between these two? So when we say domain, so these are the set of all the possible inputs for a function. So anything that we can input into the function. And then the codomain, on the other hand, is the set of the allowable outputs. Okay? Again, if we say domain, so we refer to the set of all possible inputs for a function. And the codomain, on the other hand, is the set of all the allowable outputs called the codomain. So for example, if we have a function that adds 1 to a certain integer, so what would be the domain and the codomain there? So if we have, from the word itself, we add 1 to the integer, so the domain will be the set of all the integers, right? And if we add 1 to an integer, it will also produce an integer. Okay, so what the function does again is to add 1 to the input x. So that means that our domain will be the set of all integers, and then the codomain will be the set of all integers as well, because we can only input an integer and it will only produce an integer. Okay, so we can also write it like this. So if we assign A with an output B, so we can write it as f of A equals B. So if we visualize it in our function machine will be the f, and it accepts an input A and it produces an output B or f of A also. Okay, and we also have what we call the range of f. What is the range of f? Range of f is the set of all images of elements of A. But what is image? What are images? And what are images of elements of A? So A is the input, right? And then it produces an output B. Okay, so we call B as the image of A, and then A will be the pre-image of B. And what is the range of f, or what is the range of the function? So what are the set of all possible outputs here? So the range of f is the set of all images of elements of A. So basically, we consider all the elements of the set A, and then what would be the outputs, or what would be the set of all images. So that would be the range of f. So let's understand it with an example. So for example, we have two sets here, set A, Bill, containing elements Bill, Jen, Sarah, and then Adam, and then set B contains A, B, C, D, and then E. So these are the set of grades. So we have a function f here that maps set A to set B. Okay, so what would be the domain of f? As you can see, the domain of f, as we have mentioned earlier, is the set of all inputs for a function. So what are the set of all possible inputs? Since f maps A to B, so the inputs here will be those elements that are coming from A. So the domain of f will then be Bill, Jen, Sarah, and then Adam. And then the codomain of f will be the set of all allowable outputs. So if we look at set B, the allowable na outputs are A, B, C, D, and then E. Right? So what about the range of F? So we have mentioned before that if in f of A equals B, if B is the image of A, then the range of F is the set of all images of elements of A. So essentially what we do is we substitute a certain element, let's say certain element from A into our function. What would be the output? So in this case, it would just be the A, B, C, and then E. Okay, so D will not be included. All right, so another example. So let relation R be A1, G5, Q10, and then Z22. So what will be the function that this relation determines? So essentially what we are going to do is to, let's say we can visualize it into like a Venn diagram, wherein, let's say in set A, it will be composed of A, G, Q, and then Z, and then it will be mapped, the elements in A will be mapped to another element, let's say another set B, which would contain A, 1, 5, 10, and then 22. And this relation here represents the mapping wherein A is being mapped to 1. And then G, which is an element of A, is mapped to 5, which is an element of B, and so on. So what is the function that this relation determines? So first is we must determine the domain, codomain, and the range of F. So the domain will be the set of all allowable na inputs. So in this case, it's A, G, Q, and then Z. And the codomain will be the set of all allowable outputs. So it could be any integer or any positive na integer. So our codomain here is Z plus. But for the range only contains the set of all images of images of A rather. So it would be just 1, 5, 10, and then 22. So essentially, if we say the range, so you can try to visualize the relation and then let's say map the elements in A and then into the elements of B. So the range will only contain those elements that are actually mapped or assigned to an element in A. All right? So, yeah. So, kung i-map nyo sila sa Venn diagram, tapos there is an actual na parang you see an arrow coming out from the set A and then into the coming into the set B. So, yung mga inassign element from B into A, yun lang yung range. Pero pag sinabi mong codomain, yun yung set of all possible na mga outputs ng function. Okay? So determine image for each element of the domain. So in f of A, so the A, G, Q, and then Z will act like an input into our function, and then it will produce images for each element. So if for f of A, it is equal to 1, and then for f of G, it is equal to 5, as you can see, because we have a mapping for G and then 5. For f of Q equals 10, and f of Z equals 22. Okay? What about this one? So assume a function f that maps any integer x to x plus 1. So determine the function. So assuming that we have a set x, rather we have a set here that contains elements -1 to 0 to 1 and then 0. And then we have a function f that maps any integer x to x plus 1. So essentially what the function does is just add 1 to the input or to the elements of x. So for example, in -1, we add 1 to it, 0, we add 1 to it, and then 1 to 1, and then 2 plus 1. Okay? And we said earlier that what the function does is it does some computations or it does some operations to produce some output. So in this case, if we add 1 to -1, it's 0. For 0, it will be 1. For 1 will become 2, and then 2 will become 3. So we then have two sets here, and this is the mapping that is being done. Okay, so determine the domain or codomain and range of f. So all the possible na values of the domain, as you can see, we have a -1 here, and then we have a 0, and then we have positive na integers. So we can then say that the set of all possible all possible inputs domain will be z, or the set of all integers. And if we have a function that maps any integer x to x plus 1, or essentially just adding 1 to any input, what will it produce? Also an integer, right? Also an integer. So that means that the codomain will also be z, or the set of all integers. And then what will be the range? As you can see, so just look at this elements in your x plus 1 that is being mapped with an element from A. And as you can see, it is also integers. Okay? So determine image of each element of the domain. So we have f of x equals x plus 1. Okay? So the f will act like a function machine that will accept an input x, and it will produce an output x plus 1. Okay, some example functions in programming also. So the domain and then also the codomain of functions are often specified in the programming language. So have you already experienced coding functions in your programming? So for example, if you write a function, you have this syntax. So def f function f, and then it will accept a parameter x, which has a data type float, or float. So essentially what it does is the x will be the input into the function f. And what does the function f does? So it returns int of x. So you input a float x into the function, and the function will produce an integer, okay? Because it will compute for the int of x. Let's say also in Java, for example, you have a function f, and then it accepts a parameter for an input float x, and it will do some computations and then return something. Then Pascal and so on. Okay. So here are some other examples. So for example, you have the squaring function. What does the squaring function do? The squaring function accepts an input x, and then it produces an output f of x equals x squared. Okay. And then, so what do you think will be the domain and then the codomain of this squaring function? So in this case, let's say if the domain of x is the set of all integers, then f of x equals x squared will probably be the set of positive na integers, because if you do a squaring function and if you square an integer, regardless if it's negative or positive, then it will always produce a positive na integer. Okay? And then, or maybe pwede din whole numbers. Kasi if we have 0, then if you square 0, then it will produce also a 0. Okay? So, yeah. And then we also have the successor function, wherein it accepts an input n, and then what this successor function g does is it adds 1 into the input. And then we also have the constant function, and then what the constant function does is just accept a constant value, and it also produces a constant, so it doesn't really change. Okay. Yeah. So more examples. So assume a function that assigns the last 2 bits of a bit string of length 2 or greater to that string. So for example, if we have a string s, so this is a bit string s, and it is 11010. And what we want to do is a function that will assign the last two bits. So we just have to look at the last two bits of S, string S. So in this case, it is 10. And we also have a restriction here wherein the bit string has a length 2 or greater to that string. Okay, so f of S will then be f of the string S, which is 11010. And what the function does is assign the last two bits of the bit string. So it is 1, 0. Okay, other examples, if we have F11, so the last two bits of 11 is also 11. The last two bits of F of 001 is 01. So, okay, so what will be the domain of F? So the domain of F will be the set of all possible inputs, and we have specified here that it is a bit string of length 2 or greater. Okay, and the codomain of F could either be only 00 or 01 or 10 or 11 because we only have these possibilities. So for example, let's just modify the string S. So it could be 1110 00, or it could be 11001, or in this case it's 11010, or it could be 11011. So these are the only possibilities. Okay, these are the only possible na mga last two bits that we can have. Okay, so what will be the range of F? So it will also be 00, 01, 10, and then 11. Right? Okay, so that's all for this topic.